Hello my friends and welcome to this new practical activity on support vector machines. Alright, so we already built two classification models, logistic regression and KNN. We got the best results so far with KNN and now let's see if SVM can beat it. Alright, so before we start, as usual, let's make sure everyone here is on the same page, and if that's the case, then follow me into part 3 classification and then section 16 support vector machine SVM. And we're going to start with Python, of course, as usual, and in this Python folder you will get two files. The first is the same dataset social network ads.csv containing 400 observations where each observation is actually a customer who bought, yes or no, a SUV that is advertised on social networks. And for each of these customers you have the age, the estimated salary. So these are the two features, and with these two features you will predict the dependent variable purchased, meaning whether or not the customers bought the SUV. So 1 means yes, the customer bought a previous SUV, and 0 means no, the customer didn't buy any SUV. Alright, so same data set, and of course the second file is this support vector machine implementation in the IPYNB format, which you can either open with Google Collaboratory or Jupyter Notebook. And as far as I'm concerned, I'm going to open it with Google Collaboratory, but feel free to choose your favorite IDE. Alright, so let's put that file here, actually here, and right now it is loading the notebook, laying it out, and in a second we should have it open. There we go. Alright, so that's the whole support vector machine implementation, and of course it is exactly the same as before. In order to re-implement this, we will only have to change the code cell where we build and train this model, because indeed this implementation results from the exact same classification template that we made when we built the logistic regression model. We saw clearly when implementing the k-nearest neighbors model how indeed we only had to change one cell and how this template worked super well for that model. So here for SVM we're going to do exactly the same. We're just going to leave all the cells as they are, as they actually were in the logistic regression model, and we will only re-implement the cell where we built the SVM. Alright, so let's do this. Let's create a new copy of this file because this file is in read-only mode. So let's click here, save a copy in Drive, and this will create a copy inside which we will indeed be able to modify the implementation and mostly to re-implement that code cell to build the SVM model. Alright, perfect. So at the beginning, of course, we start with the data preprocessing phase with all the same outputs displayed on the notebook. So that's all good. Then we apply feature scaling because, you know, it improves the training performance. And anyway, it's never bad to apply feature scaling. And finally, there we go. That's the cell we have to re-implement together because indeed it is the one that differs with respect to the previous implementations. So let's click this trash button here to, re-implement it again. Let's create a new code cell. And now, my friends, over to you. Once again, I would like you to please press pause on the video and try to implement that code cell yourself. And that's because I not only want to train you in machine learning, but also train you on how to be independent with machine learning. So right now, the exercise I want you to do is to do some research in the scikit-learn API to figure out which class allows to build the SVM model. So you will find it very easily actually, because there is no trap in the name of the class or the name of the module. So I trust you will totally be able to do this exercise successfully and mostly know which method to use at the end to train that SVM model on the training set. Alright, so please press pause, and now in 2 seconds I'm going to give you the solution. Alright, let's do this. So I already have the scikit-learn API opened. That was for the nearest neighbors, the k-nearest neighbors, which we implemented previously in the previous section. We used this class, k-neighbors classifier, and now the next thing we would like to find in this API documentation is the module that contains the class that allows to build the SVM model. So naturally, where could we find it? Here, should we scroll back up or scroll down? Well, let's hope that, the name of the module starts with an S, because here, the modules are organized by alphabetical order. So since here we are at N, nearest neighbors, let's hope that the name of the module we're looking for starts with an S, like support vector machine. So let's scroll down and random projections, semi-supervised learning, and there we go. support vector machines, hello. That's exactly what we were looking for. Support vector machines. So that's not the name of the module. The name of the module is SVM, but same, that stands for support vector machines. All right, and then, well, the hardest part is done. Now, according to you, which estimators, because here you have all the basically support vector machines based machinery models. And so according to you, which one do we need to take here? Well, we actually have two options. We could either take the linear SVC, which will directly build the linear support vector machine model, or we can take this one, SVC, and choose a linear kernel. All right, and we will actually go for this option because in the next section we will study the kernel SVM models, which, as you might guess, allow us to choose some different kernels in our SVM, including the linear one and the non-linear ones, like, for example, the very famous one, RBF.